All right, time for the last video in this section. In which case you see I wrote no video. So I'm not going to make a specific one about this chart. It's the best one, you need to use it, but I know there's one, if not two or more videos that go through a practice worksheet that talk about all of this. So this is a very cool thing to learn. And with this, we're talking about either constant, linear, quadratic, or cubic equations. And we do have to know a little bit about what goes on in the middle. But again, those other videos deal with that. But as promised, dun, 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 at the very first video, I said, hey, this is where we're going to get to. Well, now we're there. And we need to figure out what's going on. So when we did it before, I don't know, I think we had half the answers here and almost nothing down at the bottom. But now I have faith that you can do this. So we need to determine what type of an equation this is. So our choices are linear, oops, I'm going to put in order, constant, linear, excuse me, quadratic, cubic. Okay. So what type? Well, a constant is going to be a straight horizontal line. Nope. A linear equation is going to be, it's going to go straight. Okay, straight at an angle. It'll be a straight line that goes at an angle at your graph. Nope. A quadratic, oh, wait a minute. I can even make this better. This is when it's A is plus, this is when A is negative. Quadratic is going to be a smile if A is positive and a frown if it's negative, which pretty much leaves us cubic. So cubic equations generally look like that. How am I going to draw that? Like that. Or, whoops. Or they might have a bigger loop in there. These are the positives. And they can go downhill. Or they can have downhill with a loop-de-loop. Well, that's not fair. With a wobble, not a loop-de-loop. No loopy-loops are allowed here. Negatives going like that. Okay, so clearly this is a cubic. Check. The value of A, if I look at my start, my end, one of the things you can do when you're analyzing a graph is just take your ruler. You don't have to draw the line, but you can see it's going uphill. So it's odd because it's a cubic, it's going uphill. Oopsies, must be positive. Oh, it's not a degree. All right, because it goes uphill like that. Now our start. And yes, I do that almost every time because my brain just, I always want to number them differently. Let's just go with that. So I am starting, if I read this way, starting in 3, and I'm ending in 1. And I forgot to do something. Oops. There. Okay. X-intercepts. There are 2. There's one there. There's one there. We did have this part before. I remember that. -1, 0, 0, 0. Be careful on the assignments because I often ask how many x-intercepts and then I want the coordinates. So if I said that there's 2 x-intercepts and these are the coordinates of them, there's always 1 y-intercept. Okay, so there's the x-intercept. There's the other one. This is also the y-intercept. 0 and 0. And my domain, what do you remember? Is domain is my favorite set of all x such that x is an element of real numbers. if you go to that chart on page 9, and we go down to where it says domain, look at that, all the way across. Oh, and by the way, number of y-intercepts 1, all the way across. So much simpler. If I have a chart, big chart to fill in a bunch, like the assignment you're going to get, yeah, I just go fill those in first. Don't even have to worry about it. Okay, what else we got? My range. Oh, well, you know what? I have my form here. I might as well look. That's the joy of this. So we said it's cubic, 2 x-intercepts, which we had, 1 and 1 and 3 that we wrote is, sorry, 3 to 1 XCR, and my range is y such that y is an element of real, because it keeps going. It keeps going down this way, and it keeps going up that way. Y such that y is an element of real. Oh, by the way, bring that chart back for a sec. When it comes to range, if you have nothing, put this. If you have no idea, because at least 50% of the time you're going to be right. If you're doing a straight line, so like y equals 10 or something like that, you would just put, so if my equation is y is equal to 10, then you put y such that y equals 10, right? So you're not going to put the word constant in there. I had some people do that on the last assignment, like, oh, I guess I forgot to mention that. And then what year? When it's a parabola, or sorry, a quadratic, you have to be more careful with the maximum and minimums. But follow along with this, watch the other videos, you're going to be golden. Or come see me. You know what, if you come after school, I pretty much guarantee that I can help you one-on-one, no problem, because most people leave quickly at the end of the day. Okay, back to work. Number of turning points we can see on this one. Now, key here, turning point means a complete change in direction. So we're going uphill, then we went downhill, uphill. So there's 2. Excuse me. I remember there was a question somewhere and it went like that. And people were saying, oh, that's 2 turning points. No, not really. You're going down. If I'm reading from this direction, I'm going downhill. I'm still going downhill. Wow, I'm really going downhill. You need the actual change in direction. Okay, cool, cool. Now, I always find these ones a little bit more challenging. I'm a visual learner. I want to see the picture. So, I'll let you know a secret. Shh. Don't tell the ones that haven't watched the video. If you get stuck on all of these, just go put it in Desmos. Right? So I think what we'll do is we're going to analyze it. We're going to analyze it first, and then I'll plug it into Desmos, and I'll just show you what I mean. You can double check your answers, or be told you could probably just go to Desmos to begin with. But sorry, that's a terrible thing to encourage you to do, because you're going to write a test. You're not going to have Desmos on your test, so you need to be able to do it from the equation. All right, type of equation. Well, I just finished saying you're going to have constant, linear, quadratic, or cubic, and this is none of them. So type of equation. What am I going to write? I'm going to, what I would do if I had to do this. It is of the 5th power. I'm referring to my highest exponent, which now I made it so it's hard to read. All right. So my value I'm going to highlight there. Now it looks like it's on fire. My leading term, my value of A is, whoops. I'm going to change that. That should be sine of A. I don't actually want the value. I just want to know it's positive. And it's 5, so that's odd. So that means odd positive, and this is where this comes into, is going to go like that. I don't know what happens in the middle, but it's going to be odd positive. So that means it's going to start in 1, in 3, end in 1. So I guess it'd be a lot like that one. My y-intercept. Where is this? What is this crazy woman asking us to do? There's no picture. How am I supposed to? Okay, so the y-intercept, x equals 0. You can calculate it. Oops. Straighten that again. X is equal to 0. So we're going to plug in a 0 everywhere there's an x. So y is equal to -6, 0 to the 4th, plus 2, 0 to the 5th, -7 times 0, plus 2, is equal to plus 2, because all of these disappear. So here's the point where being able to find the constant saves you some time. Your y-intercept is always going to be where that constant is. So I want this to be 0 and 2. So there we go. 0 and 2. Notice I don't ask you the x-intercepts because you would have to put, well, let's just show you what it would be. X-intercept, y is equal to 0. So you have 0 is equal to -6x to the 4th plus 2x to the 5 minus 7x plus 2. So you'd have to figure out how to make that work. And to do that, you have to be able to factor it. And 1, we don't do factoring. And 2, I'm not even sure if this would factor because I just made up some numbers when I was making this question up. So I can always ask you the y-intercept. Sometimes I can ask you the x-intercept, which is where I'm going with that. Domain. Oh yeah, remember? Oop, domain. Same all the way across. Doesn't matter what power it is. So x is an element of real, and the range. Oh, wait a minute. I was about to say, I don't know, but it's odd degree. Y such that y is an element of real. That's we're going back to my handy dandy chart. So it's cubic, but it's also anything of an odd power. So whether it's 1 or 3, degree 3, or degree 5, it doesn't matter, it's odd. It's going to be y such that y is an element of real. And ta-da! And here's a playlist for the whole section should you need it. Have a spectacular day, and thanks for joining me for this fun math stuff. Bye.